Chapter 2, Section 3, Volume, Grandmaster level. A few critical thinking problems here. Number 1, the planet Saturn has an average radius of 58,232 kilometers, while Earth has an average radius of 6,371 kilometers. Determine how many times larger Saturn's volume is than Earth's. So in other words, how many Earths could fit inside Saturn? And it says, do not evaluate pi. And there's a good reason for that. In short, because it's not necessary. So how on earth do we work this out? Okay. Well, we can do this by taking the volume of Saturn and just dividing it by the volume of Earth. Okay, because that will tell you how many Earths would fit inside Saturn. All right, so what is the volume of Saturn? Well, we're just going to assume that it's a sphere. So I know that that is 4/3 times pi times the radius cubed. So the radius of Saturn was what? 58,232 kilometers. Okay, there we go. I can extend that a little bit. All right, so 4/3 times pi times the radius cubed. And I divide that by the volume of Earth. Well, that's assuming it's a sphere, pretty close to it. 4/3 pi times its radius. Cubed. Okay, so here's why it said we don't have to evaluate pi. You can work all this stuff out in your calculator, but there's no need. This 4/3 cancels out that 4/3. And pi cancels out pi right here. So in short, all I have to do is take the radius cubed and divide it by the other radius cubed. That's pretty easy. So I'll just write it out one more time, but without everything else there. Just what I need. This is 6,371 kilometers cubed. So working that out gives me approximately 763.6. Now there should be no units, okay, because I would get kilometers cubed divided by kilometers cubed. And besides, this is the number of times Earth would fit inside Saturn. So I guess I could put, I don't know, times. Okay. So what this means is you could fit almost, or pretty close to, 764 planet Earths inside Saturn. So obviously Saturn is pretty big, but not as big as Jupiter. Number 2, 4 liters of water is poured into a 20 centimeter cubic container. If a metal sphere of radius 5.3 centimeters is then submerged in the water, what is the depth of the water? Does the container overflow? The first thing to note is we're told in the question that this metal sphere, or the ball, is completely submerged in the water, so it sits below the surface. Just going to make note. The volume of the container, okay, we are told that it's cubic and the dimensions are 20 by 20 by 20 centimeters. So that means the volume is 8,000 cubic centimeters. Okay, I got that just by multiplying 20 times 20 times 20. So this is how much water the container could hold in theory. And the volume inside of everything, so that's the water and the sphere once it's dropped in. Okay, well, we're told that it's 4 liters of water that's put in there. Well, we might as well talk centimeters, or centimeters cubed. So that is 4 liters is 4,000 milliliters, or you could say it 4,000 cubic centimeters. Okay, because that is this. All right, And the sphere has a radius of 5.3 centimeters, so the volume would be 4/3 times pi times the radius cubed. And there we go. So I'm just going to add these volumes together. It's no problem. Okay. Now when you're working this out, the 4/3, you can multiply by 4/3 using your fraction button. Or you could multiply everything by 4 and then divide this by 3. It doesn't really matter. But I'm going to get approximately 4, 6, 2, I'll say 4. And this, of course, is cubic centimeters. Okay, so that's the volume of water plus the volume of the sphere. Well, I think it's obvious that is the container going to overflow? No, it's not. All right, it can hold 8,000 or 8 liters of water, 8,000 cubic centimeters. So we're not even close. We don't have to worry about that. But the question wants us to determine the water level. Okay, so how deep is the water with the ball inside? So we can work that out. Okay. Well, even though there's a sphere inside, the liquid must conform to the shape of the container. Okay, we have no control over that. So you can think of the water and the sphere as forming one rectangular prism, okay, within this cube. And we know the volume of it. We just worked it out. But of course, these dimensions don't change. This is 20 centimeters. So is this. Okay, it's this that we're trying to figure out. Okay, I'll call that the height. Okay, the height of the water level. Well, we know the volume of everything inside here. So let's just say, we know volume of a rectangular prism is length times width times height. It's the height that I want, and we've seen that formula before. That's just the volume divided by the length times the width. Okay, so I'm going to use that one. So the water level must be the volume, which includes the water and the sphere. So this is 4, 6, 2, 4 cubic centimeters. Okay, and I'm going to divide that by length times the width. Well, that's just 20 times 20, or just 400. And I get approximately 11.6, and this would be centimeters. Here, I'll put that H there. Okay, so as we can see again, it can't overflow, because if this is a cubic container, we know that this here, that's 20. Okay, so even dropping the sphere in there, it only increases the level to 11.6 centimeters. So still lots of room to spare. Lastly, number 3, a hollow pipe of length 10 centimeters has an outer radius of 2.4 centimeters and an inner radius of 2 centimeters. Calculate the exact volume of pipe material. Do not evaluate pi. Okay, so the pipe is hollow, so we're not going, in the end, we're not going to include the volume inside here. There's nothing there, it's just air. We only want the volume of the pipe, the actual material. Well, hopefully you can see that really we're just going to find the volume of a smaller cylinder, and we're going to subtract it from the volume of a larger cylinder, and whatever's left over has to be this volume in between. So that's not that hard. Now, of course, cylinders use pi, but in this case I don't want to evaluate it, so I'm going to work with the exact answer. So the volume of material is equal to the volume of the large cylinder minus the volume of the small cylinder. You could label it as outer minus inner, it doesn't really matter. Okay, so the volume of this large cylinder, the outer one, would be pi times the radius squared, and we're told that the distance from this edge to the center is 2.4 centimeters. So pi r squared h. So that's this. It's 10. Okay, and we're going to subtract pi times this inner radius squared. So that distance from the outer edge to the middle is 2 centimeters. Okay, but of course it's the same height, same length of pipe. So that's 10. Okay, so I'm not going to work all this out on my calculator evaluating pi. Okay, I'm just going to work out everything here and then just leave the pi. So I get 2.4 squared times 10. So that gives me 57.6 pi. Okay, so this is a volume, so this is cubic centimeters. Minus, I'm just going to leave pi. 2 squared, of course, is 4. Times 10 is 40. This would be pi times 40. But you would write it as 40 pi. Do not write this as pi 40. That is incorrect. There. Okay. Well, this is just like dealing with like terms in algebra. I have 57.6 pi minus 40 pi. Well, that's easily done. That just gives you 17.6 pi centimeters cubed. All right. So that is the exact answer with pi left unevaluated. And if you wanted your approximate final answer, all you have to do is take 17.6 and multiply by pi on your calculator, and you will get about 55.29 cubic centimeters. I'll put this. Done.